Hello, one. So I'll try to do 2025 AMC in this session. So what we have, the first problem, like before I actually start with this, I just want to say this is going to be my first attempt. If there are some questions that I may miss, so I'll fix them later. But for now, let's go ahead and try. So the 8 point star is given, and the what percent of the entire region is star. So this one looks like the middle four there is a 4 unit square, and if you combine those corners, that's also four, which is like half and half. And then this is also half of this square. This is like half of these each one as well. So which is why it is just going to be 50%. Okay, so number two. So the table below shows the Egyptian like letters with numbers to represent different numbers. And then, for example, 32 can be represented by this. Let's see why. Because this is 10, and then we have 3 copies and 2 copies of, okay. And then we want to know what this number will be. Okay, so the first one is this one. So we have 10,000. So I'm going to write that. And then we have 1, 2, 3, 4 of this one, which is 400. And then we have 2 copies of 10, which is like 20. And then we have 3. So 10,423. So that is choice B. Okay, so that was quick. And the next one is Buffalo Shuffle is a card game in which all the players distributed evenly among those players at the start. And Anika and her of 3 of her friends play the game. Each player will have 15 cards. So since we have like 4 people and each has 15, which means we start with 60 cards. And suppose 2 more friends join the game, how many cards will be dealt for each player? So like since we have already 4 people, if you have 2 more, which is gonna be 6 people, and then we are gonna divide by 6, so that should be 10 for each individual. Okay, so that was 3. And number 4, Lucius is counting backward by sevens, and his first numbers are given. We are looking for the 10 number. So the first is 100, and then 93 and 86. We can keep decreasing these, but I think we can use the definition of the nth term of the arithmetic sequence. We start with 100, and then we are going to subtract 9 times that 7 to get the 10th number. So 9 times 7, which is 63 subtracted from this, which looks like 37. Okay, and number 5. So Betty drives a truck to deliver the packages in the neighborhood. Those streets are given, okay. And Betty starts at the factory label F, drives to A, B, C before returning to F. What is the shortest distance in blocks she can drive? Okay, so the block looks like a horizontal or vertical distance between two vertices of each unit, I guess, square. So we start from F, so we have 1, 2, and 3. So you can go this way or that way or either way around. That's 3. And then I can go A to B. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 of that. And then from B, so 1, 2, 3, 4, 5, 6. So we should have 6 more. And then C to F, 1, 2, 3, 4, and 5, 11, 14, 24. So the smallest we can do is 24. Okay, so far we are done with 5. So the next number is the person writes the numbers after he erased one of these numbers. The sum of the remaining 4 numbers is a multiple of 4. And we want to know what number was erased. Okay, so like we can probably add and like any of these 4 and kind of see if it's a multiple of 4. But instead of doing that, I'm going to just actually take mod 4 to see their remainder. So if I take 15, so 15 is congruent to like 3 mod 4. Okay, and then 16 is congruent to 0, 17 is congruent to 1, 18 is congruent to 2, and 19 is congruent to 3. So when you add like 4 of these, the sum of the remainder should be like 0 in order for that to be multiple of 4. So when you add the remainder, so you got 6, 8, 9. So the smallest like number that we can get multiple of 8, like 4 is 8. So which means we should actually remove this guy so we can get some of the other remainder will be just 8. So that means 17 should be removed. Like if you don't buy this, then you can just like add any of these 4s and just see if that's some multiple of 4 as well. So it should be fine. And number 7, one of the most recent exam in the class is given with some percentage, and we are looking for the number of students who earn at least 80%, but less than 90%. Okay. So, we have 5 people who are getting at least 95, so which means like, I'm going to say X is larger than 95 all the way to the 100. We have 5 people. So I can write it this way as well. So the number of people like who had a score that is at least 90%, which means 90 to like I'll say 90, like maybe I should use internal notation. So like 90 to 95. So 95 is not inclusive. So this number is going to be 13 minus 5, which is 8, because we already have 5 people who actually got over 95 or equal to 95. So that would be 8 people in this range. And similarly, 85% at least means you could have 85 all the way to the, let's say, 90. 85 is inclusive, 90 is not. So we already have 13 people who had 90 or above. So that means in between 85 to 90, we should have 27 minus like 13, which looks like 14. And the last one is 80% at least, which means 80 or above. So let's go with 80 to 90. So that should be 50 minus 27, which is 23. So we are looking for the at least 80% and at most like 90, but 90 is not inclusive. So which is basically we are looking for some of these two. So over 80 and less than 90. So some of these two will be just 37. Okay, so that was number 7. And number 8, so Isaiah cuts open a cardboard cube along some of its edges to form the flat shape given on the right, which has the area of the 18 square centimeters. What is the volume of the cube? Okay, this is the surface area. So 6 times one side square is 18. So the x squared should be just 3. We are looking for the volume, which is going to be x cubed. So that should be like x squared times x. So x squared is 3. So x is going to be root 3. So that should be choice A. Okay, so that was, I guess, easy. Number 9. So we have a circle with 12 numbers, okay, and a person looks at those 6 pairs of the numbers directly across from each other. On a clock, she takes the average of each pair of these numbers. What is the average of the resulting 6 numbers? Like we can't take the average because there's only 6 pairs. Like you can take the average of 6 and 2, which is like 4. You can just continue for the other pairs as well. But at the end, so you are adding all these 1 through 12 only once. Make the pair. So which is basically I can add those, right, by just Gauss. So that will be 12 times 13 over 2, which is going to be 6 times 13. So this is the sum of those pairs, right? But we take the average of each pair, so which means we should divide this by 2. Then the average of those pair has to be 3 times 13. So that is my average. So we are looking for the average of these 6 resulting numbers, which we have 6 numbers, and then they have the sum of this guy, right? Let me see if this is average. So like when you add those, and then you divide by 2. Actually, this was the average. This was the average. Let me double check. So that's the sum of those. Yeah, when you divide by 2, this is average. So now we have 3 times 13, and we divide this by 6 because we do have now 6 different numbers as average. So I can cancel these. So that will give us 6.5. Okay, so that was number 9. Number 10. So we have the figure ABCD is a rectangle with the side 3, like 5 and 3. So it looks like this is 3 and this is 5. And ABCD rotated 90 degrees around the midpoint. So which means that should be like 2.5, and then this is 2.5. What is the total area covered by these two overlapping entire region, basically? Okay, so we have the one rectangle is 15, and then we have 2 copies of rectangle, but this middle region was counted twice, which need to be subtracted. Since we know this is 2.5 and then this is 2.5, since this is rotating that way, that means this part also 2.5. So to get this area, that's 2.5 square. So since 25 square is 625, so I can just remember that. That will be subtracted. So 30 minus 6.25. So that looks like we have 23.75. That is the choice D. Okay, so let's see the next one. Okay, so let's see the next problem. So we have a tetramino consists of 4 squares connected along their edges. Okay, and there are 5 possible shapes, which I guess these guys are below, which can rotate or flip over, and then 3 are used to complete the cover 3 by 4 rectangle. Okay, at least one of them has to be S, and then what are the other 2? Okay, so like we are told this must be one of them. So let's put it in our like 3 by 4 rectangle and see what's left over. So it looks like I can have something like this. So we have 2. I think that should be like this. And then we have this, right? Okay, so this is the one that is S, and we just need to add 2 others, which as you see from the choices, we could have maybe same as well. So, but for us to finish this part, so it looks like we need this L shape, so which is gonna be one of these L's for sure. Okay, so this is 1. That means these 2 has to be, or maybe that. But other 3 also is L, so we just need one more L, so which is why that's choice C. So the question never said it has to be different, and then I don't think we can do anything else either, so that should be our answer. And the region below shows it consists of 24 squares, each with the sideline is 1 centimeter. And the area of the largest circle can fit inside of the region, possibly touching the boundaries. Okay, so we want to get the largest circle. So since I have 2 on each kind of direction, so which is why it's kind of identical, or reflect over this midpoint. So which is why this has to be our center of the circle as well. And then we want to get the largest circle possible. So it looks like we cannot take the circle around this part. So it has to go through at most these points. And I will probably take these as well. So it looks like we can actually make a circle through these points. Because if I like extend this, that will be like a radius, and then that will be like something in between this as well. So if you connect these, you will make the circle that is inside. But if you extend a bit larger, so you're gonna go over this part, so which doesn't work. So the rest justify tag, I guess. So I can use the, let's say this right triangle. So this is 1, this is 2. So that means the radius is like √5. And we are looking for the area of the circle, which is pi times radius squared, which is 5 pi. Okay, so that was 12. And each of these even numbers on this list divided by 7, and the remain are recorded. So which histogram displays the numbers? Okay, so we have 25 numbers. Let's keep this in mind. So like you can find each numbers kind of like listing each divisors and stuff. I'll take the mod 7. So that will make it a bit easier. So 2, 4, 6. So the 8, if you take mod 7, you'll get 1. And then 10 will be like 3 more. So you can see you are just going to increase by 2 because we are just increasing by 2. But these are going to be my remainder when I take out mod 7. And the next one should be like 5. And the next one should be 0 because 7. And then we will having this pattern again. So you got 2, 4, 6, 1, 3, 5, 0. So like these guys are residue like class or just remainders, which is 7 different remainder, which is reasonable. And since we have 25 numbers, which means we are going to have this 3 times, and then we are going to have 4 more numbers. So those 4 numbers will be the numbers that we see in our list as the first 4. So which means like 2, 4, 6, and 1 should be the one that is like one more than the other, which the other has to be done like 3 times, and these numbers should be 4 times. So it looks like 2, 1, like 1, 2, 4, 6. So 1, 2, 4, and 6. Yeah, I think that's choice A. So 1, 2, no, that's not good. Okay, that is choice A. So you just have like 4 of these, 1, 2, 4, and 6. And then the other has to be 3 times because we just see the first 4 is, first 4 numbers will be kind of one more than the others. So that was the answer. Okay. So a number n is inserted into this list. Okay, and the mean is now twice as great as the median. Okay, so let's be careful. So the mean is now is twice as great as the median. So like when you look at the choices, like the smallest number is 7. So if even if you add 7 into your list, the median number is 7. So if you add anything else, so median is still 7, which means the median is regardless 7. And then the mean has to be twice as much of the median, which means this has to be 14. Okay, so let's add them. So 2, 6, 7, 7, and 28. So we have 1, 2, 3, 4, 5, but we are adding something as well. So 1, 2, 3, 6. And then when you divide by 6, you get this number. So that should be 6 times 14 for the sum. That will be 60 plus 24, which is 84. Okay, so this one and this one is 30. 14, 20, which is 50. So if you subtract 50 from both sides, so the end looks like 34, which is the choice A. If you kind of don't see this immediately, you can always plug the choices into the list and kind of get the mean and median and see which one does work, but it will take a bit longer. Okay, so the number 15, the key draws 6 by 6 grid, and he colors 13 of the units square silver. Okay, let me underline this. 13 is square are silver, and remaining are gold. So since this is 36 in total, so that means 23 has to be gold. Okay, and like he wants to like fold the grid halfway vertically, which is through this line, forming pairs or overlapping unit squares, and M and the M equals the least and the greatest number of possible gold and gold pairs, respectively. What's the sum? Okay, so if you want to get the smallest number that it will be gold and gold, we just want to make sure as many gold as possible will pair with the silver ones. We have only 13 silvers one. If you, let's say 1, 2, 3, 4, 5, 6, like 9, 12, and 13. If I take all these silvers and put the gold right across, all these silvers will be paired with the gold ones. That is going to be like 23 minus 13. So you will get 10 left. So those 10 will be the ones we will place the 5 right here, and then we'll place the 5 right here. So those 5 on each side of that vertical line will be matched. So which means the smallest m we just have is 5. So, but if you want to maximize this now, you try to make all like the silver ones goes on the, like we want the largest number gold and gold pairs. So which means we want to make the silver ones matching with the silver ones. But we have 13 of the silver ones, which means we can only have 6 and 6 silver ones to match. And then there will be one more left silver. And then one that silver will have to be matched with the one of those gold ones, which means you are going to have 22 gold left. And then those 22 gold lefts can be paired with 11 gold to 11 gold, which means 11 is the max we can have. So when you add these two, so we get 16 as our answer. Number 16 now. So 5 distinct integers from 1 through 10 are chosen, and 5 distinct integers from 11 to 20 are chosen. No two numbers differ by exactly 10. And what is the sum of those 10 numbers chosen? Okay, so like if this is the question, like is asked, like means we do have only one final answer regardless of what 5 numbers we chose. So which is why I'll just say, let me choose 1, 2, 3, 4, and 5 from the first list. But since we do know no two numbers differ by 10, then we cannot have anything that is like 11, 12, 13, all the way to the 15. So the first number I can choose like 16 from the second list. And then I can do like 17 and 18. This might be 19 and 20. Like, because the difference has to be at like nothing is 10. If you choose 5, then you cannot have 15. This is 4, then you cannot have 14. So this is one way to make that selection. But regardless of how you make it, so you're going to actually balance anyway. So that would be at least one way to get the sum. So 1 through 5 by default, so you can just say that is 15. And then we have 1, 2, 3, 4, and then 6, 10. So that is 60. And then 6, 7, 8, 9, that's 17, 24, that's 30 more. So that's 15 plus 90, which is 105. So that is choice C. This was a good one. And number 17. So in the land of the Markovia, there are 3 cities, A, B, C's. Okay. And there are 100 people who live in A. So let me write that. And 100 people who live in B. And then 160 C. Okay. And everyone works in one of these, like 3 cities. A person may work in the same city where they live. Okay. In the figure below, an arrow pointing from one city to another is labeled with the fraction of the people living in the first city who work in the second city. Okay. So meaning that like this guy, 1/4, is the people who live here but works here. Okay. How many people work in A? Okay, so let's see. So if you take the 1/4, that's 25, which means there is like 25 people going this direction, right? So, and then let's see. And then this is 100 divided by 5, which is 20 people going this direction. So we are looking for the number of people who work in A, so which is why we don't need to do all this. We just need to know the arrows pointing to A or going from A. So which is why 1/3 of 120 is 40, so that should be 40. And 1/8 of 160 is 20. So let's see what we have. So first things, like we lost 25 and 20 from 100. So we had 100, we lost 25 people and 20 people, but we earn 40 and 20. So that should be plus 40 plus 20. So these will cancel. So you got 15 plus 100. So that looks like 115. So yeah, I think that should be the answer. So number 18, the circle shown below on the left has a radius of 1 unit, and the region between the circle and the inscribed square is shaded. Okay. In the circle on the right, 1/4 of the region between the circle and inscribed square is shaded. Okay. And the shaded region in both circles have the same area. and we want to find the capital R. Okay, so like this is kind of obvious because if you connect this is the diameter, so that's 1. If I want to find the shaded region, so I need to find the area of the circle, which is pi times like 1 square. Subtract the area of the square. Since this is 2, I can divide this by root 2 to get the length, so which is root 2 and root 2. So the area of the square will be just root 2 times root 2, which is 2. So the pi minus 2 is the shaded region on the left. So on the right, like I can do the same thing. This is R and this is R, so that's 2R. So if I divide 2R by root 2, I will get the one leg, which is this guy, for example. So the area of the circle is pi times radius squared minus the area of the square, which is going to be like 2R over root 2 times 2R over root 2. But when I do this, I just find this, and this region. We need to take the 1/4 of this. So let's simplify this. I'll say like as the next step, so I have pi minus 2. So you do get like pi r squared, pi r squared. I can multiply actually both sides by 4. And minus, like 2 times 2 is 4, and then this is 2, 4 over 2 is 2. So minus 2r squared. And what else do we have? Nothing else. Okay, so that this is the pi r squared. This is 4 pi. This is 2r squared. So we are looking for the r squared. Maybe we can pull the r squared as a factor. So that should give us pi minus 2 is equal to, maybe I should have multiplied. So this was 4 times this. Okay, 4 times pi minus 2. These guys will cancel. R squared is 4, R is 2. So this is one thing we can do. Or second thing, we can just use the similarity approach, which can give us the same thing as well. Anyway, so next one is 19. So 2 tons AB is connected by the straight road, 15 miles. Okay, 5, 5, 5. Traveling from one ton A to B. The speed limit changes every 5 miles, 25, 40, and 20 miles per hour. 25, 40, okay. And 2 cars one at A and the other one at B start moving towards each other at the same time. Okay. They drive exactly the speed limit in each portion of the road. How far from town A will these 2 cars will meet? Okay. So first thing I'll say, so like if I want to start from here to see how long it's going to take to get this point, so 5 is the distance. If I take the 5, divide by 25, because that's my speed, so that will take 1/5 hours, which is like 12 minutes, right? Okay, and then if I do the same thing, 5 over 20, so that looks like 1/4, which is 15 minutes. So meaning that like, since this is like faster than this guy, so this A will be actually be here in 12 minutes, but this guy is not going to be here yet. So we will have 3 more minutes for this B to be here. After this is at B, then they're going to have the same like speed, so which is no big deal. So, but this guy will have 3 more minutes. So like the speed right here is like 5 over like 40. This is the time. This is the distance, this is this is distance, this is the speed. So this will take the entire distance, 5 over 40, right? But let's not worry about this yet, maybe. So like we want to know how long the person A will actually move from this location, this point to this way in 3 minutes, because this guy will be there at that 3 minutes. So 3 minutes will be 3 over 60 hours, and the speed is gonna be like 40 miles per hour. 120 over 60 is 2 miles. So meaning that the person A will actually go 2 more miles in this direction when the person B is right here. So that will be A, that will be B. So now this is at this point and this is at this point, and they now both have the same speed. So that means they're going to meet in the middle. And this was 5 miles, and then that should be right in the middle is 2.5. 2.5. So we are looking for 5, 2, and 2.5, which is 7. I mean, this is actually 5. Oh, no, this is 3, 1.5. Okay, because this was left was 3. So I just see this as 5. Okay, that's 1.5 plus 2 plus 5, which is 7, 8.5, which is 30. Okay, I think that was slightly challenging. Okay, number 20. The Sarika, Dave, and Rajiv are sharing a large block of cheese. They take turns cutting off the half of what remaining and eating. Okay, so the first Sarika eats half of the cheese. Okay, so I'll say S, D, and R. So if you eat one half, then one half left. Then Dave eats one half of the remaining, which means Dave will eat half of this, which means 1/4 will be left. And then the same thing going on with the R, so 1/8 will be left. And then 1/16 will be left, 1/32 left, 1/64. And then this is just gonna continue until this is too small to see. About what fraction of the original block of the cheese does Sarika eat? So like we just need to add these guys, right? And then if you keep doing this, this is gonna be a geometric series with the common ratio of 1/8. And if you remember, the sum was A over 1 minus R. So the A is like 1/2. And then R is 1/8. So that should be like 1/2 times 8/7. So it looks like 4/7. So if you kind of don't see this immediately, like you can try maybe choosing a like number to start with and then kind of going with that number. So that should also work. Okay, next one is 21. So it's getting a bit challenging. So we have a school assigned the grades 1 through 7, right? Into these pods, A through G, 1 grade per pod, okay? And some of those are connected by the walkways, okay, as given. The school notes that each pair of the connected pods has been assigned the grades differing by 2 or more grade levels. So, okay, 1 and 2 will not be in the right. Okay, 2 more grade levels. Okay, I see. So we should have the numbers that is off by at least 2. Okay, and then we want to find the numbers in those CEF. Like, it's like we just see this number, like C is attaching every one, right? That is actually the one that we can actually start with, except this one. So if you are gonna attach to almost everything except 1, then you can only not be next to if you're off by 1 with the other number. So which is why you can kind of start with the either 1 and 2 or 6 and 7, kind of start with the label and C. I'll go with this is 6, then this must be 7 in that case. Okay, so then this guy is the next number in between. I should start with that maybe. I will not go with, let's say, 5 because that will be up by 1. I cannot go 6 either. So 4 is the first I can start with. If this is 4, then I can go with this like 2 because that should be 2 different. And now let's see if there's something we can do with this. Now, like if this is of like 4, I cannot have 3. So I cannot have 1 and 2 either. So 1, 3 doesn't work. So we cannot have 5. So nothing is actually working with this case. So we cannot continue because there's nothing really working with that. If I go with this is 4 and then this is 1, now we can just try maybe something else, but it doesn't look like we have anything either. Because if I have 2, that doesn't work, 3 doesn't work, 4 doesn't work, 5 doesn't, 6 doesn't, 7 doesn't. So which means 4 actually does not help. So let's go with 3. So we didn't try 5 because that was next to this as well. So if this is 3, then we can just say maybe like this is gonna be 5. That could be 5. And then we have 4 that doesn't work here. So 3, no, 2, maybe this is 1. So if this is 1 and this is 3, that does work. But 5 and 6 doesn't work either. So I think we cannot have that either. So that means if this is 3, then this might be 4 instead of 5. But it doesn't work 4 because of the 3. So I can just do maybe 2, 1. So 1 is the only one I can do now. So if this is 1, then this might be, let's say, 5. No, 1, 2, 3, 4, 5. So it doesn't look like we have anything. So that's why I'll just skip the 1 as well. Okay, so then if this is 2, right? So then that might be 1 and 3 doesn't work. 4 might be. 5 and 6 doesn't work. So 4 looks like the only choice for this case. And now we have like 3 doesn't work. 4, no. 5, no. 6, no. So it doesn't look like 4 is gonna work either. So that looks like we have only 1 left for this guy. If this is 1, then this might be 3. So 4, like 5 for this guy, no works. So that's not 3 is not working. So if this is like 4, then that might be like 3 doesn't work. 5, no. 6, no. That doesn't work anything. So if I go with like 5, then this might be 3. So that should be fine. And now we have like 2 numbers left. So we are missing 1, 2. Let's say 2, 3, 4. So 2 and 4 can be next to each other. So that could be 4 and this could be 2 because this can't be 4. And that looks like this is working. And then we can always check this to see if that's really the case. We are looking for C, E, and D. So that looks like we have 10 and 12. So that's choice A. So this was a bit challenging to get the pair. Maybe there's a shortcut, but I don't see immediately. So that was the answer for me. Number 22. Now, like we have a classroom has 35 quotes, hooks, and the person likes to cut them equally spaced so that there is the same number of empty hooks before the first quote, after the last one, between every quote and the next one. And suppose there is at least 1 quote and at least 1 empty hook. So how many different ways can we arrange this? Okay, like we can start with like maybe leaving 1 empty in front and then kind of skipping, putting 1 and kind of doing that way. Like, well, but I think that should be okay. But I'm gonna try a little bit different. Let's say we are gonna have C number of quotes. Let's say in this case, like we have 2 based on the figure. And every time you have 1 quote, you are gonna have like 1 more region, like to the left and to the right, right? If you have 5 quotes, then you have 6 different like regions around it. So which means we can say like C is the number of quotes, right? And then plus C plus 1 will be the number of gaps in between. So I will say number of gaps is X. When I add this, I should get 35. So like X is the number of like gaps, I will say. And then C is the number of quotes. So, and then this has to be 35. So from here, so you got CX plus C plus X is gonna be 35. So C plus 1, this is kind of our assignment. And then X plus 1 is gonna be 36. So I cannot have 1 because that will force this to be 0. So 218 or 312. So I can have 4, 9, 6, 6. But I can swap these as well. So which means we have 1, 2, 3. That's 6 plus 1 is 7. So I should have 7 pairs. So like if you don't buy this, you can always go with the listing because 35 is not a huge number. So I think that should be fine. So 23 is how many 4-digit numbers have all 3 of those following properties? Okay, the 10th digit and the 1st digit is both nice. So it looks like this. The number is 1 less than a perfect square. I'm gonna call this is n. And this is a 1 less than perfect square. So I'll say x squared minus 1. And the number is product of exactly 2 prime numbers. Okay, I'll say this is equal to P1 times P2. And okay, so the first thing I can try, since the square number is kind of helpful, I can add 1 to both sides. If I add 1 to this 99, you get 2 zeros at the end. So you will get like n plus 1 should be like something 0, 0, right? When you add 1 to both sides. So, and then that will be equal to x squared. But this is perfect square. Like when you look at the square numbers, like 1 square, like 1, 2 square, like 4, and 3 square is like 9. When you look at the last digit of any digit, so you are not going to get 0 unless you are squaring something that will end with 0. So which means my x should be a number that will be ending with 0. So like since we are looking for the 4-digit number, then maybe we can just maybe start with 30 square, which is like 900, but that doesn't work. So the 40 square is going to be 1600. So that should be the smallest number. And then you can go with 50 square as well. So like at the same time, like when you kind of remember that the n plus 1, which is this number, is equal to, actually n is equal to difference of this. So like if I want to write this as x minus 1 times x plus 1, so the Rn is equal to product of two numbers that is off by 2. But we already know that's going to be two prime numbers. So we need that we are looking for two prime numbers that is going to be off by 2. And when you square a number, that should add and 0. So which is why we can look for the numbers that is close to these multiple tens. Like for example, this guy, like 39 and 41. And the next one is like 49 and 51, 59, 61. And then we got 69, 71, and 79, 81, 89, and 91. So like we cannot take the 29 and 31 because that's going to be not 4-digit. So this is not prime 39, and then 51 is not, 69 is not, 81 is not, and then 91 is not. So it looks like we have only one pair. So that looks like choice B. I think I'll double check, but it looks like that's the only pair. So the next one is 24. So we have triple-eight, ABC. Okay, B and C is 6 degrees. Okay, and AB and DC are equal, all positive integer. And the perimeter is 30. Okay, how many non-congruent trapezoids satisfy the condition? So like as soon as I see the 60s and triple-eight, I like to kind of remember these are also 120, but I like the equalizer triangle. The first thing I'll probably try is kind of extending this way. Okay, and then if I do this, so this is 60 and this is 60, that is also 60. If I name this is like A, that is also A, this is also A, this is B, then this is B. And this larger one is also equalized triangle, so it means this is A plus B. So when you add the sides, so you got 1B, 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 which is 3B, and 2A, it has to be added up to this. And let's start with finding those pairs. If I choose B is 0, that means this is 15, but can't be. So I should choose at least 2 to balance those coefficients. That's going to be like 24, so that's 12. And if I increase by this 2, so that should decrease by 3. So that's 6 and 6, and that's 8 and 3. So I cannot have more than this. So we have 1, 2, 3, and 4. So it looks like this one, but I will double check if I have time. So the next number, the Michaela finds all possible ways to draw the path in this 5x5 diamond shaped grid. Each path starts at the bottom, okay, and ends at the top, moving in 1 unit northeast or northwest. So she computes the area of the region between each path and the right side of the grid. So we are adding only right side, okay. 2 examples are given. What is the sum of the all possible areas? Okay, so like this is interesting. The first thing I would probably think of, like, let's see how many paths are possible. Like, we have like 5 and 5, which is basically 10 steps, and we want to choose 5 in one direction, which is 10 choose 5 ways that we can make that movement. So that's 10 times 9 times 8 times 7 times 6 over 5 factorial. So these will cancel, these will cancel. So it looks like we have 3 times 8 times 7 times 6. Okay, let's keep that in mind. But every time when you do this like figure, so you know you are dividing the 25 into two regions. So one is what you can, one is you don't count, but they are kind of symmetric because like let's say if you take this region, 1 unit, so you are taking the other 24 is not taken. So if you take the right side of this, you take everything 24, not one. So which means you're actually taking the half as many of those entire regions. So entire region is 25 every time, but we are taking the half of this, which means we can actually multiply this by 25 half. So if I do that, so you should get like 425 is 100. And then you got 3, 7, and 6, which is 21 times 6. So that will give us, let me double check. 6, that will be 12. And I think I messed up with something. So tens will cancel. So 3 will cancel. 3, 8, 7, 6. And then 25 over 2. So cancel that. So that's 4. That's 100. 21 times 6. So that's 6. 126, which is going to be 12,000. Okay, I think I messed up. So 10, 9, 8, 7, and 6, 5. Okay, I'm missing 4. Okay, I messed up with 4. So if I do have that 4 as well, then I'll see. Let's cancel that. So then I cancel that 4 because I need to divide by 4. So then that was okay. So now we have like 3, 7, okay, 18 and 7. So 18, 7, and 25. Okay, so if I multiply this 7 by 25, that's going to be 175 and then 18. So that should be 0, 56, 60, 14, 175, 5, 1, and 3. So 3,150. I think that's choice B. Okay, so I hope that was not wrong with calculation. So it looks like reasonable. So anyway, so that was the last question. So let's see what we have at the end. I'll just grade this after. Okay, I'll see you. I'll see you next time.